Welcome to the last video of chapter 1 of our introduction to Java book, and also the last of the first series of videos on our YouTube channel regarding chapter 1. And in this video we'll go a little more deeper into the Java compilation process. As you might have noticed previously, we did touch upon Java compilation, but it was very briefly, and it was a short primer into the compilation process. But in this particular video, we'll be going over the entire process in detail. Especially if you're new to Java, or even if you're looking for a refresher, this is the right place to be, so it can help you understand exactly how this process works, because that would help you get better understanding of the Java language that you're trying to use to build software. So before we jump into the details, let's quickly understand why compilation is important in Java. That's an important aspect to understand before jumping into the more technical parts of this video. So generally speaking, unlike interpreted languages, Java is both compiled and interpreted, making it a very portable and efficient language. This means Java programs can run on any device with a Java virtual machine, regardless of the underlying operating system. But how does this magic happen? Why does Java work in pretty much any operating system just because of the presence of the Java virtual machine, or JVM? Let's break this down step by step, basically. Understand exactly why being a compiled and interpreted language means that the Java is portable and efficient, and why JVM is such a magical tool that it can help you use Java in any operating system. So let's move to the next part of the video. So basically, for any compilation process to work, first you probably write a Java code, basically. So if you are watching this video for the intro book, or even if you're watching this on YouTube without the book, please write this code on an online Java IDE called JDoodle. And if you are familiar with our book, you would see that we have given 3 different platforms on the book's chapter 1 on exactly what online IDEs you could use, or you can even set it up on your local environment. But based on this, write this code basically in your in your file, and create a .java file basically. And save this code there. Even if you don't have an IDE, you can just create a .java file and save this in a notepad, basically. Once you've written this code, you'll have your Java source code, which is human readable. But computers basically don't understand anything other than their own language. They cannot understand this human readable language that you've written, that we call Java, directly. So they can only understand machine code, which basically consists of binary instructions. So what we need to do next is to convert this code into something that the computer can execute and understand. That's where the Java compilation process comes in. So basically, if you can look at the screen right now, the compilation process starts. You've written that code, you've saved the .java file. You'll notice here that we have a terminal window on this slide, and it's saying javac, then file name .java. So whatever your file name is, and then the .java extension to that file name, that is your Java file. So use the javac command and then your file name .java to start the compilation process in Java, basically. And the Java compiler is basically called the javac in short. It translates your human readable code into bytecode, a lower level representation of the program. But wait, what is bytecode? And why does Java use that instead of compiling directly into machine code? Let's try to understand that a little better. So here you can see we have a high level source program, basically our statement or our code that we write. Then a compiler that compiles the code file into binary, and then the executor that executes that file on your computer, as you can see in this diagram here. So statement, high level source program, moves through the compiler into the compiled code file, and then that is pushed to the executor, which executes the output of your code and executes its instructions onto the computer, basically. So with that understanding, we need to move to understanding bytecode, basically. What you need to understand with Java bytecode is that after compilation, the javac compiler generates a file called helloworld.class file. Let me move that to a somewhat better understanding here. So you can see here, we have a Java source code file .java file, which is our written code right here. and then it is compiled by the compiler, which is Java compiler or Java C, into bytecode or the .class file, right? The file contains bytecode. Basically, Java C file contains, so the .class file contains bytecode. And this comes basically after the compilation process. Our source code is converted into the .class file, which is our bytecode, and this is not human readable, but it is designed to be executed on any machine that has the Java virtual machine. So this .class file, which is the bytecode, is something that can be executed on the computer using the Java virtual machine or JVM. So basically, this makes it very, very easy for any platform to use to use Java, because we just need to have the Java virtual machine to translate this bytecode into a machine code that is executable by any machine. This is a major advantage because it allows the same code to be run on different platforms without any modification. So generally speaking, you can think of bytecode as an intermediate language. It's not machine code yet, but it's closer to being executable. Unlike C or C++, which compiles directly into machine code specific to an operating system, Java compiles into bytecode, ensuring portability across devices. So let me put it this way, right? So think of it this way. You have in C and C++, the code is compiled to be specific to the operating system, right? In Java, instead of compiling the code or machine code specific to a machine or operating system, what it does is it creates an intermediate file called bytecode or the .class file, which can be interpreted by the Java virtual machine, virtually present anywhere. Now, the virtual machine can be installed in most operating systems, which means this bytecode can be used in multiple operating systems. This is the advantage of Java, and that is what we mean by bytecode. So let's move back a little bit because I wanted to explain a few more things here, and I had to jump ahead because we need to go over bytecode in a little more detail. So if you look at the overall process in this diagram here, this is how Java code in its entirety moves through its life cycle. So a developer writes a test.java file here, as you can see here, which is compiled by Java C, which generates Java bytecode file, which is executed by JVM on any operating system. So Java code to machine code moves in this cycle, as you can see. Java source code is compiled, then transformed to bytecode by Java compiler, and then implemented and executed by the Java virtual machine on the underlying operating system, basically. And here you can just simply see that, an interpreter this is a very, very base abstraction where a statement or source program can be interpreted into an output, basically. But this diagram is not that important. Now that we understand that, we need to move into JVM execution, basically. So step 4 in any process is execution using JVM of Java code. Now that we actually run the program, we use the Java virtual machine with this command. We use the word Java and write the compiled file's name and to run Java code, basically. So what happens behind the scenes once you do the JVM execution of the compiled file is that the JVM loads the hello world.class file, and then Java class loader loads the bytecode into memory. The bytecode verifier then checks bytecode for security and correctness before execution, and the just-in-time or JIT compiler translates bytecode into native machine code for better performance. The machine code executes and we see the output hello.world. As you could remember, the code that I asked you to add into IDE right at the start, that's the ultimate output of that code. The JIT compiler plays a very crucial role in improving the execution speed by translating frequently used bytecode into native code at runtime, reducing interpretation and overhead, basically. Now we basically understand the execution process of Java in very, very close detail. So after that, what we need to understand is basically what are the advantages of Java's compilation process. Java basically uses a two-step process instead of a direct compilation like C or C++. What is the advantage of this approach? Basically, what it does is that it makes Java platform independent. which means that you can write code once and run it anywhere thanks to JVM on any operating machine in any operating system that has JVM. So that is a major advantage of Java. Similarly, it makes your bytecode more secure. Bytecode verification before execution helps prevent malicious code execution and creating problems in your code base or in your operating system or computer itself. Then Java, this approach makes Java very, very efficient. JIT compilation optimizes frequently used code paths for faster performance and execution of your code, which makes it very, very useful tool for professional developers in big software platforms. And this approach also makes it easier to debug and maintain your code, since bytecode is the same across different platforms and no change is needed. This hybrid approach to compilation followed by interpretation balances performance, security, and cross-platform compatibility, making Java a very, very powerful and a widely used programming language in the world. And there you have it, basically. If the complete Java compilation process from source code to execution works like that, and now that you can understand exactly how Java process works, how Java is actually executed on your machine, and why it is used that much, because it can be executed on multiple machines. You're you're one step closer to understanding and actually implementing Java in an effective manner. So again, if you like this video, please like, subscribe, and hit the notification bell for more content from Smart Architecture Programming. And if you're following along the book, congratulations, you've completed 1 out of 17 chapters, and we're moving in the next video on chapter 2, which covers the next important topics that you need to learn to become a master in Java.